In today's note, what we're going to be looking at is compound interest. So this is going to be a little bit different from simple interest. We looked in our last lesson, we looked at the comparison between the two, but instead of having to make a table every time we want to calculate compound interest, we have a specific formula that we can use. So this formula, what we have here is A equals P times 1 plus I to the power of N. A is the total amount of the investment, so we have seen that variable before, or we can also call it the future value. The principal is P, or present value, and again we know what that is, and I is the interest rate as a decimal per compounding period. So the key thing here, last time we talked about the interest rate, it was R, but now it's I and it's per compounding period, and N is the total number of compounding periods. So we're going to look a little bit at that compounding period part, and we're going to look at a table. And the table shows how to convert yearly interest rate and term for various compounding periods. So your question will usually give you the compounding period, and it will tell you the yearly interest rate, and usually the length of the term in years. So what we have to do is we have to make some changes to that. So if we see compounding annually, annually means once per year. Your I value or your interest rate remains unchanged because it would be given to you in years. And same with your term. It would be unchanged as well. If we look at semi-annually, semi-annually means twice a year. So our interest rate, what we have to do to that is we have to divide by 2, because if we're given the interest rate for the entire year, we have to divide that by 2 to get it per compounding period. And then for our N value, we multiply by 2. So if we're given the number of years, we have to multiply them by 2 so that we can get what our total number of compounding periods are. Quarterly means 4 times a year. So we have to divide by 4. And we have to multiply by 4. Monthly. So monthly means 12 times a year. And hopefully you can kind of see the pattern now. The interest rate, you divide it by 12. The term, you multiply by 12. Bi-weekly means 6 times or 26 times a year. So we divide by 26 and we multiply by 26. And then lastly, weekly is 52 times a year. So we have to divide by 52 and multiply by 52. So what we have to do for the I and the N are 2 small calculations before we can actually put them into our equation. So what we're going to look at in the next 2 examples is just what we might see in the question and how we would have to actually calculate that. So for our first one, we want to calculate the I value. So this is the interest rate per compounding period. So what we have to do is first we have to turn our percent to a decimal. So 6 divided by 100, 0.06. So again, you can do that in your head or you can use that as a calculator. I'm going to automatically do that in the next ones, but we should know that we need to turn a percent to a decimal. So what we do next then is for our I value, we take that percent, so that yearly percent, and because it says semi-annually, that means basically 2 compounding periods. And because there are 2 compounding periods, we need to divide this yearly rate by 2 we get 0.03. For weekly or 5% weekly, we're going to take the decimal, so 0.05, and divide it by 52, because that weekly term means that there are 52 compounding periods that we're dealing with. So 0.05 divided by 52 equals 0.000962. And lastly, for quarterly, same idea. Take the decimal, divide it by the compounding period. Quarterly in this case means 4. So we're going to divide by 4, which equals 0.004375. Now, there are a lot of decimal places. I would say try to keep at least 3 values beyond the zeros. So for this last one here, you could round that to 0.00438 if you wanted to. If you round too early, then it may change your answer by a bit. So try to keep your as many decimal places as you can. For example 2, we're calculating the n value. So the n is the total number of compounding periods. So if we look at A, we're looking at compounded quarterly for 5 years. So compounding quarterly means there are 4 compounding periods. And if it's for 5 years, so 5 years times 4 compounding periods equals 20. So that means there are 20, or therefore 20 compounding periods in 5 years. So I'm not going to write a therefore statement for all of them, but just so you understand what it's talking about, or what this value actually means. For B, compounded semi-annually for 18 months. So there's 2 kind of things we need to do here. Semi-annually means twice a year, but we're given it in months. So this is kind of a throwback to that simple interest lesson. We want to convert this to years. So I'm going to take 18 months and divide by 12 months, because there's 12 months in a year, and I get 1.5. That means there are 1.5 years for this example. So 1.5 years times 2 compounding periods a year equals 3. So there would be 3 compounding periods in this question. And finally for C, it's compounded biweekly. So biweekly means 26. So 2 years times 26 times a year equals 52 times in total. In example 3, now we're going to get into a question where we actually have to go through and find the future amount, or the future value. So it says, determine how much money you will have if you invest $500 at 4% per annum for 6 years, compounded semi-annually. So this per annum part, we may not have seen that before, but all that means is per year. So again, remember I said that the percentage or the interest rate will be given to you per year, but you need to calculate what the value is per compounding period. That's why we divide it by whatever the compound number is. So what I want to do is I want to start out with my variables, A, P, I, and N, and go through the question and try to find my information. So first part is determine how much money. So that means we are looking for the future amount. So I don't know my A value, how much money you will have if you invest $500. So that is my starting amount, or my principal. So P is 500 at 4% for 6 years, compounded semi-annually. So this is where we have to do our 2 small calculations. We know it's 4%, so 0.04, but I need to divide that by the compounding period, which is 2. So 0.04 divided by 2 equals 0.02. So that means that my interest rate per period, or per compounding period, is 0.2. Then finally, for my n value, It's 6 years multiplied by the compounding period, which is 2. So twice a year for 6 years equals 12. Now what we have to do is just go through. We have our formula, A equals P times 1 plus I to the power of N, and we can plug in our information. And once we do this, this just becomes a calculation that we can solve. So $634.12 is our answer. So therefore, you will have $634.12 at the end of this 6-year period. Example 4 is the same idea. So Amy borrows $500 to buy a car. She agrees to pay it back at the end of 4 years. If the interest rate on the loan is 6.5% PA, slash A, compounded quarterly, how much will she repay at the end of 4 years? And then secondly, how much interest does she pay? So there's a couple things here. So first, she borrows $500 to buy a car. And again, we're going to want to start off with our A, P, I, and N. So our P value is 5,000 because that's how much we're starting with. She agrees to pay it back at the end of 4 years, so we know we're going to have to include that. The interest rate on the loan is 6.5% slash A. So again, this just means per year. So similar to the per annum, it's just another way it can be written. Compounded quarterly, and then how much will she repay at the end of the year? So we're looking for the future amount. Our interest rate per compounding period, we take the yearly interest rate, so that's 6.5%, divide it by 4, because our compounding period is 4, and we should get 0.01625, and then for our N value, it's 4 years times 4 compounding periods, so 16 in total. Now we just have to get our formula and plug in our information. So 5,000 times 1 plus 0.01625 to the power of 16. And when we calculate this, we should get $6,471.11. So therefore, she will owe $6,471.11. So that is the first question in this example. If we read it carefully, the second question mentioned how much interest does she pay? Let me actually use a different color. The second question is asking how much interest does she pay? So here what we have to do is we have to kind of use our calculation. Remember, A equals P plus I, right? So the future amount, right, or the total, is equal to your principal plus your interest. Let me spell that correctly. So taking this, we can then rearrange it so that the interest is equal to the total amount minus the principal, or what you started with. So in this case, I is going to equal your total amount, so $6,471.11 minus the $5,000 principal equals $1,471.11. So therefore, he pays $1,471.11 in interest. So that is just another small calculation. So just be careful, make sure you read the question to fully understand what they're asking. In our next example, again, I'm going to write out the A, P, I, and N because we are going to have to find those. So Jamal invests $3,000, so that's key, in a GIC that pays 2% per annum, compounded monthly, for a term of 10 years. How much will he have at the end of the term? So I've highlighted the key things as I've gone through it. If you didn't, feel free to go back, reread it, and then highlight some of the important things. So Jamal investing $3,000 is the principal. The A value, we don't know because we're looking for how much will he have in the future. The I value, we know the yearly percent is 2.4%. We have to divide that by the compounding periods, which is monthly, so 12. The N value, we know it's 10 years, but we have to multiply that by 12 because there are 12 compounding periods per year because it's compounded monthly. So 10 times 12 is 120. Now I can just take my formula and plug in the information. So 3,000 times 1 plus, go back and calculate this, 0.002. So 3,000 times 1 plus 0.002 to the power of 120. We should get a value of $3,812.83. So therefore, you will have $3,812.83. So that's just looking at compound interest. Again, this is a shorter way of doing it than having to make that table like we did in the last lesson. Keep in mind when you calculate it, your I and your N value, you do have to do a small calculation beforehand. So again, make sure you're reading carefully, make sure you can find the compound number so that you can do those calculations. Once you do that, you just have to plug your information into the question or into the formula and solve. And finally, just make sure you read it carefully. Make sure if there's any secondary questions of such as how much interest do you earn or is there at the end of the term.